Hello students, welcome to Bodha Academy. I am Kamlakar, lecturer in physics. In this video, we will be discussing about concepts and formulas related to motion in a straight line. Distance. The total length of actual path traversed by a body is called as distance. Displacement is change in position of a body from initial position to final position. If x1 is initial position of a particle at time t1 and x2 is final position of a particle at time t2, then displacement is equals to final position minus initial position. That is, displacement is equals to x2 minus x1. Note, distance is scalar while displacement is vector. Distance is always positive, while displacement may be positive or negative or zero. When motion of a particle is along a straight line and is in same direction, then magnitude of displacement is equal to distance. Distance is always greater than or equal to magnitude of displacement. Examples of distance and displacement. Example 1. A particle moves from A to B and then from B to C as shown in figure. Then distance traveled by particle is equals to 3 plus 4, that's equals to 7 meter. Displacement of particle is nothing but AC, which is equals to square root of 3 square plus 4 square, that's equals to 5 meter. Example 2. A particle moves along the circumference of a circle of radius r and completes half revolution as shown in figure. Then distance traveled by particle is equal to pi r. Displacement of particle is equal to 2r. Example 3. A particle moves along the arc of a circle of radius r and of angle theta as shown in figure. Then distance traveled by particle is equals to r theta. Displacement of particle is equals to 2r sine theta by 2. Note, when final position coincides with the initial position, then the displacement of particle is 0. But distance covered by particle is not equal to 0 in this case. Example, a particle moves along circumference of a circle of radius r and completes one revolution. Then distance traveled by particle is equals to 2 pi r, while displacement of particle is 0. Next topic, speed. It is distance covered by a body in unit time. Average speed of a particle is defined as total distance traveled by total time taken. Consider a particle traveling along a straight line ABC as shown in figure. Let AB is equals to S1, BC is equals to S2. Let particle covers a distance S1 with a speed V1 and in time T1. Let particle covers a distance S2 with a speed V2 and in time T2. Then average speed of particle is given as V average is equals to S1 plus S2 divided by T1 plus T2. Case 1. Equation 1 can also be expressed as V average is equals to V1 T1 plus V2 T2 divided by T1 plus T2. When particle covers distance S1 and distance S2 in equal intervals of times, that is, if T1 is equals to T2, then the above equation becomes V average is equals to V1 plus V2 divided by 2. Equation V average is equals to S1 plus S2 divided by T1 plus T2 can also be expressed as V average is equals to S1 plus S2 whole thing divided by S1 by V1 plus S2 by V2. If particle covers equal distances, that is, if S1 is equals to S2, then the above equation becomes 2 by V average is equals to 1 by V1 plus 1 by V2. This equation can also be expressed as V average is equals to 2V1 V2 divided by V1 plus V2. Note, if a particle covers 1/3 of total distance with a speed V1 and second 1/3 of total distance with a speed V2, and third one third of total distance with a speed v3, then average speed of particle is given as 3 by v average is equals to 1 by v1 plus 1 by v2 plus 1 by v3. This equation can also be expressed as v average is equals to 3 v1 v2 v3 whole thing divided by v1 v2 plus v2 v3 plus v3 v1. Note, speed is always positive because distance and time cannot be negative. Next topic. Velocity is rate of change of displacement. Magnitude of average velocity of a particle is given as v average is equals to x2 minus x1 by t2 minus t1, where x1 is position of particle at time t1 and x2 is position of particle at time t2. Also, magnitude of average velocity of a particle during a time interval delta t is equal to slope of straight line joining initial and final points on position time graph. Velocity of a particle at a particular instant of time is known as instantaneous velocity. Instantaneous velocity is given as v is equals to dx by dt. Note, speed is scalar while velocity is vector. Speed is always positive while velocity may be positive or negative or zero. SI unit of speed and velocity is meter per second, but kilometer per hour is also used as a unit. 1 kilometer per hour is equals to 5 by 18 meter per second. Next topic, uniform velocity. It is defined as the velocity whose magnitude and direction do not change during the motion of body. Example, consider a particle traveling along a horizontal straight line in same direction as shown in figure. Then uniform velocity of particle is 10 meter per second. Next topic, non-uniform velocity. It is defined as velocity whose magnitude or direction or both may change. Example 1. Magnitude of velocity of a freely falling body gradually increases though direction remains same. Example 2. In circular motion, magnitude of velocity may be same, but direction of velocity will be continuously changing. Next topic, acceleration. Acceleration is defined as rate of change of velocity. Magnitude of average acceleration of a particle is given as A average is equals to v2 minus v1 by t2 minus t1, where v1 is velocity of particle at time t1 and v2 is velocity of particle at time t2. Let v1 is equals to u at time t1 is equals to 0 and v2 is equals to v at time t2 is equals to t. Then magnitude of average acceleration is given as a is equals to v minus u by t. This equation can also be expressed as v is equals to u plus at. Also, magnitude of average acceleration of particle during time interval delta t is equal to slope of straight line joining initial and final points on velocity time graph. Average acceleration is vector and its direction is along the direction of change in velocity. Average acceleration may be positive or negative or zero. If velocity of particle increases with time, then particle is said to have positive acceleration. If velocity of particle decreases with time, then particle is said to have negative acceleration. Negative acceleration is also called as retardation or deceleration. If particle moves with uniform velocity, then its average acceleration is zero. Acceleration of particle at any instant of time is known as instantaneous acceleration. Instantaneous acceleration is given as a is equals to dv by dt. The equation a is equals to dv by dt can also be expressed as a is equals to v into dv by ds. Next topic, acceleration due to gravity. Neglecting air resistance, let a body be dropped from certain height. Then it falls towards earth with a constant acceleration. This constant acceleration is called as acceleration due to gravity. Its value is 9.8 meter per second square on Earth. Next topic. The following equations are known as equations of motion and can be used only when acceleration of a particle is constant. First one, v is equals to u plus at. Second one, s is equals to ut plus half at square. Third one, v square minus u square is equals to 2as. Fourth one, Sn is equals to u plus a into n minus half. In these equations, u is initial velocity of particle, v is final velocity of particle, a is acceleration of particle, s is distance traveled by particle in time t, Sn is distance traveled by particle in nth second. Let us discuss about difference between s and Sn. In the figure, s is equals to distance covered by body in 4 seconds and s4 denotes distance covered by body in fourth second. Note, when a body starts from rest, then its initial velocity is 0. When body comes to rest, then its final velocity is 0. When a body moves with uniform velocity, then its acceleration is 0. Next topic. Equations of motion for a body under non-uniform acceleration. We know that instantaneous velocity is given as v is equals to dx by dt. This equation can be expressed as dx is equals to v dt or integral dx x1 to x2 is equals to integral v dt limits t1 to t2. Hence, magnitude of displacement is equals to area under velocity time graph. Second one, acceleration is given as a is equals to dv by dt. This can be expressed as dv is equals to a into dt. On integration, we get integral dv v1 to v2 is equals to integral a dt limits t1 to t2. Hence, change in velocity is equals to area under acceleration time graph. Next point. Also, acceleration is given as a is equals to v into dv by dx. Cross multiplying, we get v into dv is equals to a into dx. On integration, we get integral v dv limits v1 to v2 is equals to integral a dx limits x1 to x2. Next point. If a bullet loses 1 by nth of its initial velocity while passing through a plank, then number of such planks required to just stop a bullet is given as n square by 2n minus 1. Next topic, freely falling body. For a freely falling body, initial velocity u is equals to 0. Consider a freely falling body from a height h. Let body reaches a point B at time t. Then magnitude of velocity of body at point B is given as v is equals to gt. Let body touch the ground at point C. Then magnitude of velocity of body at point C is given as v is equals to under root 2gh. The time of fall from A to C is called as time of descent and it is given as time of descent is equals to under root 2h by g. This equation can also be expressed as h is equals to half gt square. Note, for a freely falling body, distance traveled by a body in nth second is given as hn is equals to g into n minus half. Note 2, as time of descent is equals to under root 2h by g, and this equation is independent of mass, size, shape, and material of the body. Therefore, it can be concluded that a feather and a coin dropped from same height in vacuum reach the ground simultaneously. Note 3. Instead of free fall, if a body is thrown down with an initial velocity u from height h, then it reaches ground with a velocity v is equals to under root u square plus 2gh. Next topic. Consider a body projected vertically up from origin along y-axis. Let body reaches a point B at time t. Then magnitude of velocity of body at point B is given as v is equals to u minus gt. Let point B be at a height h from the ground. Then h is given as h is equals to ut minus half gt square. Also at point B, magnitude of velocity of body is given as v is equals to square root of u square minus 2gh. On reaching topmost point C, velocity of body becomes 0. Maximum height attained by body is given as h is equals to u square by 2g. Time taken by body to reach the topmost point is known as time of ascent, and it is given as time of ascent is equals to under root 2h by g. Note 1. When a body is projected vertically up from ground, then distance traveled by body in nth second is given as hn is equals to u minus g into n minus half. Note 2. A body projected vertically up from ground covers 4.9 meter in the last second of its journey. Note 3. A body is projected vertically up from ground. It reaches topmost point and then falls back. Neglecting a resistance, the time of flight is given as t is equals to 2u by g. Note 4. A body is projected vertically up from ground. It reaches topmost point and then falls back. When it reaches the point of projection, then magnitude of velocity of return is equals to magnitude of velocity of projection. Next topic. A body is projected vertically up with a velocity u from the top of a tower of height h. Let t be time taken by a body to reach the ground, that is, t is time of flight. Then relation between height of tower and time of flight is given as h is equals to minus ut plus half gt square. Velocity with which body touches the ground is given as v is equals to square root of u square plus 2gh. Maximum height attained by the body from ground is given as capital H is equals to small h plus u square by 2g, where small h is height of tower. Note, a balloon is ascending up with a velocity u. When it is at a height h above the ground, a stone is dropped from it. Then in this case also, the following equations are valid. H is equals to minus ut plus half gt square and v is equals to under root u square plus 2gh. Last topic. A stone is dropped into a well of depth h. The splash of sound is heard after time t. Then this time t is given as t is equals to under root 2h by g plus h by v, where v is velocity of sound in air. Its value is 332 meter per second at 0 degree centigrade. Under this YouTube video, press like symbol. If not subscribed, then select subscribe. Share this video to your friends and classmates. Thank you for watching this video.